Right now, as you listen to this, a point of light is falling through your window or through the walls of whatever dark room you are lying in. It left its source 4.37 years ago. It has crossed 41 trillion kilometers to reach your eye, and it did that at the fastest speed anything in this universe is permitted to travel. That point of light is Alpha Centauri, the nearest star system to our own. And here is what most people get wrong about it. They believe the barrier is distance, or money, or the will to try. None of those are the real problem. Right now, the fastest object human beings have ever built is moving through space at 191 kilometers per second. That is the Parker Solar Probe, and at its closest pass around the Sun, it reached a speed that would carry you all the way around the whole Earth in about 3 minutes. Hold that for a moment. Around the entire planet, in the time it takes to boil water. And even at that impossible speed, it would still take 6,600 years to reach the light now touching your window. Let that number rest where it lands. 6,600 years. Longer than writing, longer than the wheel, and that is our fastest machine. Voyager 1, the most distant thing our species has ever sent anywhere, is slower still. At its steady drift, it would need something closer to 73,000 years to cross that same gap. Take every civilization in recorded human history and lay them end to end, one after another, and you would have to do it more than 10 times over just to fill the wait. Not the story of one people, the story of all of them, repeated and repeated again before the ship ever arrived. And here is the part that undoes the easy answer. A faster rocket does not fix this. That is the misconception. The quiet one almost everyone carries without ever noticing they carry it. We imagine the gap is simply a matter of building a better engine, of pushing harder, of wanting it more. But the thing standing in the way is not our ambition. It is an equation. It was written down more than 100 years ago, and it has never once been broken, and by the end of these movements you will understand exactly why it closes the argument before the argument can even begin. So tonight we are going to move slowly through 4 things. First, what that distance actually means, not as a figure on a page, but as something you can feel settle into the weight of your own body. Then, what the physics of propulsion quietly forbids, the wall that every engine we have ever imagined runs straight into. Then, what a journey of that length would do to anything we were brave enough to build, and to anything soft enough to ride inside it. And finally, what is actually waiting at the far end, if by some miracle we ever manage to arrive. None of this is anything you need to hold on to. You do not have to remember a single number. Let them pass through you the way that light passes through the glass, touching you for a moment and then gone. If these slow journeys through the dark are the kind of thing that carries you down towards sleep, you can follow along here at Gravity of Sleep, and there will always be another one waiting whenever you need it. That is all. Nothing more is asked of you tonight, so get comfortable. Let your weight settle fully into whatever is holding you. The bed, the chair, the floor, the dark. Feel your shoulders come down from wherever they have been quietly holding themselves. There is nowhere else you need to be, and nothing else you need to do. The nearest star has already waited 4.37 years to reach you. It can wait a little longer while you close your eyes. Let your breathing slow. Let the room go soft and quiet around you. Let's begin. Begin with the distance, because every wall we are going to meet tonight stands on top of it. Not the machines, not the money, not the will to go. The distance first, set down gently, and then held still until it stops being a word and starts being a size. The nearest star to our own sun lies 4.344 light years away. Say that slowly. 4 1/3 years, but of light, not of walking, not of driving, not of any flight a body has ever taken. That small word, light year, is the thing doing the hiding. It sounds like a measure of time, and it is easy to let it slide past as though it meant only a little more than 4 years of something. It does not. It is a measure of distance. It is the distance that light itself crosses in a single year, moving at the fastest speed this universe will permit anything at all to move. Set it down in the planar numbers your body already trusts, and it comes to roughly 41 trillion kilometers. 41,000 billion. A 4, and then 12 zeros trailing quietly off behind it. Here is one way to hold it. Imagine you could drive there. An ordinary car, an ordinary speed, 60 miles an hour, the kind of steady pace you might keep on an empty highway late at night with no one else on the road. Now imagine you never stopped, never slept, never slowed, never once lifted your foot from the pedal, not in your whole life, and not in any life that came after yours. Driving like that, without a single pause, it would take you somewhere close to 47 million years to arrive. Not 47 years, not 47,000, 47 million. Longer than there have been creatures anything like us walking on the Earth. And that is the near star, the close one, the one we call our neighbor. You do not need to do anything with that number. You do not need to keep it. Let it stay enormous somewhere off to the side while you stay small and warm and still exactly where you are. And notice already that I have been calling it a star. One star, a single point of light like our own sun. It is not. Alpha Centauri is 3 suns, not 1. There is a yellow star a little larger than our own, and beside it a smaller orange one, the two of them slowly circling each other. And then, off on its own, a dim red ember of a star called Proxima, cool and faint and small, only about 1/8 the mass of our sun. Proxima is the nearest of the 3, and even it sits at a distance from its 2 companions that is hard to speak aloud, something like 13,000 times the gap between the Earth and our own sun. So even the destination is not one place. It is a wide, cold, scattered neighborhood, and the space between its own members is already vast. But set that aside for now. Forget, for a while, what waits there. The problem tonight is simpler and older than that. The problem is only reaching it at all, because of course we have never driven. We have flown. We have built machines to move faster than any living thing has ever moved, and the honest thing to do is to walk that story forward slowly, one machine at a time, and watch what happens to the distance as we do. Watch it refuse to shrink. Start with the farthest we have ever thrown anything at all. On the 5th of September, in the year 1977, a rocket rose from Cape Canaveral in Florida, carrying a small, clever spacecraft named Voyager 1. It was never meant to leave the solar system. It was built to visit the great outer planets and send their portraits home, and it did exactly that. But a machine that has been falling outward for that long does not stop. It is still going now, tonight, while you lie here in the dark. It is the most distant object human hands have ever made, tens of billions of kilometers out, so far away that its faint radio whisper now takes the better part of a day to reach us. And it is quick, about 17 kilometers every second, roughly 61,000 kilometers in a single hour. It crosses more than the width of a great city in the time it takes you to draw one slow breath. And if you pointed Voyager 1 at the nearest star, if by some accident of aim it were already flying straight toward it, at that speed, faster than any bullet, faster than anything a human being has ever ridden, it would arrive in a little more than 73,000 years. Sit with that gently. All of recorded human history, every written word, every remembered ruler and forgotten harvest, every war and every quiet wedding, adds up to something like 5,000 or 6,000 years. 73,000 years is that entire span. Everything we have ever set down about ourselves, lived over and over, more than 10 times, end to end, before the ship so much as arrives. And already, quietly, I have misled you a little. Because Voyager 1 is not our fastest. It is our farthest, but not our fastest. and the difference matters more than it sounds. If 73,000 years feels like the ceiling of what we can do, let me lift it, and let the lifting make Voyager feel almost small. In the year 2024, a spacecraft called the Parker Solar Probe fell closer to the Sun than anything we have ever sent, diving in through the thin outer edge of the Sun's own burning atmosphere, and as the Sun's gravity dragged it inward, it accelerated to a speed no machine of ours had ever touched. 191 kilometers every second, around 690,000 kilometers in a single hour. At that pace you could leave the Earth and sweep past the Moon in a little more than half an hour. It is, right now, tonight, the fastest object our species has ever built, or ever moved, or ever will have moved, until we build the next one. You can let your shoulders soften here. None of this is a test. Let the number be large without holding on to it. Because here is what all that record speed actually buys you. If the Parker Solar Probe, at its very fastest, were aimed at Alpha Centauri and simply let go, it would still take roughly 6,600 years to get there. Better than Voyager, yes. More than 10 times better, but 6,600 years is still older than the oldest pyramid. It is still longer than any nation, any language, any faith has ever survived unbroken. And the deepest part of it, the part that closes a door you did not hear open, is this. For all that speed, for all that record-breaking fire, the fastest object we have ever made is moving at only 64 thousandths of a single percent of the speed of light. Not 1%. Not a tenth of 1%. 64 thousandths of one. Against the speed that the distance is measured in, our greatest machine barely stirs the needle at all. You might feel there is one obvious trick still left on the table, and you would be right, and we have used it. You let the giant planets do the work for you. You swing a spacecraft in close to Jupiter, that vast heavy world, and you let its gravity fling the ship onward like a stone in a sling, stealing a little of the planet's own motion for free. Do that with the best chemical rockets we know how to build, the very same family of engines that has launched every crewed mission in all of history, and you can push a probe towards something near 150,000 miles an hour. And the distance answers the way it always answers. At that speed, the crossing to Alpha Centauri comes to around 72,000 years, and that number, that already unbearable number, is a lie of omission, because it counts only the going. It says nothing at all about the stopping. Every one of these figures, the 73,000, the 6,600, the 72,000, is the time to fall past the star, not the time to arrive at it and stay. Each one is the time to tear straight through that distant system in a single afternoon, at a speed that would let nothing slow you down. No landing, no orbit, no lingering, just a blur and then the dark again on the far side. To actually stop, to slow a ship down out of those speeds and settle into that neighborhood of 3 suns rather than shooting through it, takes as much effort as the speeding up did, and usually a great deal more. None of the headline numbers you have just heard include a single second of it. They are the optimistic version. They are the story with the hardest half left out. So the distance stands there, unmoved, 4.344 light-years wide, exactly as wide as it was when we began, having swallowed our farthest machine, and our fastest machine, and our cleverest borrowed shove from Jupiter, without so much as flinching. And underneath every one of these attempts, underneath every engine we have ever lit, and every one we have ever sketched, there is a single hard rule, a piece of arithmetic more than a century old, that quietly decides how fast anything carrying its own fuel can ever hope to go. It is the reason the stopping costs so much. It is the reason the numbers stay so cruel. And it is where we turn next, but not quite yet. Before we follow that rule down into the cold place where it lives, stay a while longer with the number itself, because the number has a history, and the history is really a history of us, of how, across a single human lifetime, we kept staring at that same unmoved distance, and kept inventing new ways to imagine crossing it. Each one grander than the last, each one making the one before it look like a child's drawing. You can let this part simply wash over you. There is nothing here to hold on to, nothing you will be asked to remember in the morning, just a slow procession of dreamers, arriving one after another, each of them certain, for a little while, that they had finally found the door. Begin in the early 1970s, in a room of ordinary engineers. Between 1973 and 1978, a group of them, working under the name of the British Interplanetary Society, sat down to do something no one had ever seriously attempted. Not to wonder about a starship, to design one, fully, down to the fuel and the frame, and the way it would one day slow its own engines. They called it Daedalus, after the craftsman of the old story who built wings that truly flew. And their ship was not even aimed here, not at these three suns. It was pointed at another star entirely, a dim red point called Barnard's star, because at the time that one looked more promising. 5 years of evenings and arithmetic, a complete interstellar vessel rendered in ink, and it was, for its moment, the most serious answer anyone had ever given to the question of how. Hold that picture gently. A machine built to touch another sun, drawn entirely by hand, on paper. Now watch the paper turn quaint, because in 1994, a Mexican physicist named Miguel Alcubierre, working in Wales, published something that made the whole idea of a faster ship feel almost embarrassing. Why push a hull through space at all, he asked, when you might instead bend space itself, gather it up in front of the vessel and release it behind, so that the ship sits perfectly still inside a travelling bubble while the distance simply folds toward it. No speed limit broken, no fire, no fuel in the old sense, only geometry rearranged. On paper it was beautiful. It fit inside the mathematics of relativity without tearing them. And for a short season it seemed the Great Wall had a hidden gate after all. The price of opening that gate, we will come to, and the price is not kind. For tonight, only notice how far we have climbed already, from a metal ship you could weigh in your hands, to a warp in the fabric of the cosmos, in the space of 20 years, and still the number sat there, 4.344 light-years wide, patient as it has always been, because a dream is not a departure. For most of human history there had not even been a reason to go. The suns of Alpha Centauri were just that, suns, points of light with nothing known to circle them. Then, in 2016, that changed. Astronomers found a world, a planet, given the plain name Proxima Centauri b, just a little heavier than the Earth, moving in the warm band around Proxima, the smallest and nearest of the three stars. Suddenly the crossing had a shore. Suddenly the 40 trillion kilometers of emptiness had a place on the far side worth reaching, a solid ground that might, for all anyone yet knew, feel something like home. Whether it is anything like home is a question for a later hour, and the answer is not a soft one. But in that year the number stopped being only a distance. It became a destination. A destination pulls harder than a distance ever could, and that same year, in the spring of 2016, 3 men stood up in a great city and made the boldest promise yet. Yuri Milner, who had built a fortune in the world of the internet, Stephen Hawking, whose mind had spent a lifetime among exactly these scales, and Mark Zuckerberg. Together they placed $100 million behind an idea that made even the warp bubble feel like an old man's reverie, because it was small. Not a 50,000-ton fusion giant, not a folding of the universe. A chip, a sail no heavier than a moth, carried forward not by burning anything at all, but by the pressure of light itself, a beam thrown from the surface of the Earth. Thousands of them, a swarm of them, flung outward at 1/5 of the speed of the very light that pushed them. The great ship had become a handful of glittering seeds. Whether even seeds can survive the throwing, we will come to. Notice only the shape of the climb. In 40 years we had gone from weighing a starship in tons to weighing it in grams. Let your shoulders soften as you watch it climb. None of this is yours to carry. And then the dreams reached forward through time and set a year down on the calendar. In December of 2017, at a gathering of the people who study the Earth and the sky, an engineer from NASA stood up and described a mission with a date attached to it. Launch, he said, in 2069, 100 years after the first human footprint was pressed into the dust of the moon. Travel at 1/10 of the speed of light. Arrive around the year 2113, 44 years after leaving. A specific promise, tied to an anniversary, pointed straight at these three suns. For many of you lying here in the dark, that is an arrival you would never live to see, and neither would the engineer who proposed it. It was less a plan than a hope wearing the clothes of a plan. It carried no official name. It had no money set aside for it. It was a date, and a wish, and a direction. So there it is, the history of the number, laid out end to end. A ship of iron in the 1970s, a fold in space-time in the 1990s, a world discovered to sail toward, a swarm of light-driven ships, a launch date set for a century after the moon, each one making the last feel quaint, each one climbing from something you could weigh in your palm towards something the size of the whole sky. And you would think, watching a climb like that we were getting closer, that all this ingenuity, all this money and genius stacked up across 50 years must have narrowed the gap by something you could measure. Here is the crushing truth, and I will say it just once, quietly, and let it settle over you like the dark already settling in your room. In all of that time, across every one of those dreams, not a single gram of any of these ships has ever left the Earth. Every one of them still lives only where it was born, on paper, in equations, in the minutes of a meeting. And the reason they stay there, the reason not one of them ever quite becomes a machine, is not a failure of nerve, and it is not a shortage of money. It is that same rule waiting underneath them all, older than any of these dreamers, a single line of arithmetic that decides, before the first bolt is ever cut, exactly how much any ship is allowed to carry, and exactly how fast it is ever allowed to go. The man who first wrote that single line of arithmetic was not an engineer with a rocket to sell, and he was not a general with a war to win. He was a half-deaf schoolteacher in a quiet Russian town, a man who spent his days explaining geometry to village children, and spent his long evenings, alone, working out in careful longhand exactly what it would take to leave the Earth altogether. His name was Konstantin Tsiolkovsky, and in the year 1903, the very same year that two brothers lifted a fragile wooden aeroplane a few feet above a windy beach in North Carolina, he set down something far quieter than their flight, and in the long run far heavier. He wrote the equation that every rocket ever built must obey. Not most rockets, not the clumsy early ones alone, every single one of them, from the first pinch of black powder in a paper tube to the last great starship anyone will ever draw on paper. All of them bound by the same short line that a deaf man found first, by candlelight, more than 100 years ago. You do not need the mathematics tonight. Let the letters and the symbols drift right out of the room. What matters, the only thing that matters as you lie there in the dark, is the shape of the truth underneath it, and that shape is cruel in the gentlest imaginable way. A rocket has nothing to push against. There is nothing out there to lean on. No road, no air, no wall, no floor. So a rocket moves in the only way anything can move in an empty place. It throws a part of itself away. It carries mass, and it hurls that mass backward as hard as it possibly can, and the throwing is the only thing that pushes the rest of it forward. Every ship that has ever climbed off this planet has moved by flinging pieces of its own body out into the dark behind it, harder and harder, and riding the recoil of its own thrown weight. And here is where the gentle cruelty begins to close its hand. If you want to go a little faster, you must throw more mass. But the mass you have not thrown yet, the fuel still sitting quietly in the tanks, is mass you are dragging along with you the whole time. You have to accelerate your own unburned fuel too, so you need fuel to move the payload, and then you need more fuel to move that fuel, and then you need more fuel still to move the fuel that moves the fuel. It folds back on itself, over and over, each layer heavier than the one it carries, each new tank demanding another tank beneath it. Not a straight climb, not a fair, honest slope where a little more effort buys a little more speed, something that curves upward and away from you the harder you push. Because the relationship Tsiolkovsky found is not gentle, and it is not straight. It is exponential. To go twice as fast does not cost you twice the fuel. It costs you far, far more than that. Ask for a small gain in speed, and the fuel you need rises on a modest slope. Ask for a little more, and the slope steepens under you. Ask for a great deal of speed, the kind of speed that could carry a ship across 4 1/3 light years in anything like a single human lifetime, and the fuel required does not rise. It erupts. The tank swells until the ship is almost nothing but tank, a vast, trembling ocean of propellant, and somewhere up near the nose, a thin sliver of metal far smaller than the fuel it must burn to move it. The actual small thing you wanted to send to the stars, riding on top of a mountain of the fuel it needs just to leave. Let that settle for a moment. You do not have to hold it. Let your shoulders soften into the bed while it sits there. The ship is mostly fuel. The traveler is almost an afterthought, and the equation is not finished with you yet. Everything I have just described only gets the ship moving. It only accelerates you away from home. But a journey to another star is not a throw. You do not want to hurl a probe past Alpha Centauri at 1/5 of the speed of light and watch it vanish into the black on the far side, having glimpsed the place for a few blurred hours as it tore through. You want to arrive. You want to slow, and turn, and stay, and look. And to slow down, a rocket must do the very same thing all over again, only in reverse. It must throw mass to brake, exactly as it threw mass to build up speed, which means it must carry all of the fuel for stopping the entire way there, which means it must first accelerate all of that heavy stopping fuel up to full cruising speed, which means it needs still more fuel at the very beginning just to push the fuel that will one day, decades later, slow it down again. Almost every travel time you will ever read, every clean and confident headline number, quietly leaves this half out. They tell you how long it takes to get there. They do not tell you that stopping, in the merciless arithmetic of that deaf schoolteacher, very nearly doubles the whole impossible budget one more time. Getting there is only half of the sentence. The other half, the staying, the slowing, the arriving gently instead of shattering through, is written in the same unforgiving ink, and it is every bit as long. This is the real reason our fastest machines are still so heartbreakingly slow. Not because our engineers are timid, not because nobody has tried, not because we simply have not spent enough money yet, because the equation will not be reasoned with, and it will not make an exception for us. Think of the Parker Solar Probe, the fastest object human hands have ever made, falling toward the Sun at 191 kilometers in a single second. 191 kilometers, gone. In less time than it takes you to draw one slow breath, and even that blistering, record-breaking speed is only about 0.06% of the speed of light. Even that, pointed at Alpha Centauri and left to run, would take somewhere near 6,600 years to arrive. Longer than all of written history. Longer than every empire, every language, every name we have ever carved into stone, laid end to end. And here is the quiet knife of it. No chemical rocket, burning the very finest fuel we know how to mix, can push a useful payload to even 0.1% of the speed of light. 0.1%. Say it softly to yourself. It sounds like almost nothing, and it is almost nothing. a thin whisper of the speed that light itself keeps without effort. And even that thin whisper is beyond us, beyond chemistry, beyond every mixture of fuels we have ever poured into a tank. The best we can do is a small fraction of that whisper, and Tsiolkovsky told us why, in one line, before the first aeroplane had even properly flown. So when you imagine a great sleek ship rising on a pillar of fire and turning its nose toward that faint double point of light, understand what is really happening underneath the drama of it. The fire is not power. The fire is the ship eating itself. Every second of thrust is another piece of its own body thrown away into the night, and the equation is standing there the whole time, patient, unblinking, counting. It does not care about our courage. It does not care about our longing, or our deadlines, or the round anniversaries we would love to launch upon. It only weighs. It weighs the fuel against the speed, and the speed against the stopping, and it hands back the same verdict every single time, in a voice too quiet to argue with. You can feel that verdict in your own body, in a small and homely way, if you let yourself. Think of trying to carry water across a long desert on foot. You need water to survive the walk, but the water itself is heavy, and the more you carry, the slower you go, and the slower you go, the longer the walk, and the longer the walk, the more water you need to carry. At some point the pack is nothing but water and you can barely lift it, and still it is not enough to reach the far side. That is the rocket, exactly. That is the whole tragedy of leaving, folded down into a weight on your shoulders. The thing that lets you travel is the same thing that holds you back, and the two of them are locked together in an embrace that tightens the harder you strain against it. This is not one obstacle among many. It is the flaw beneath all the others. Every ship we spoke of, every design that lives only on paper, every dreamer with a blueprint and a lifetime, ran first into this. Before the exotic fuels, before the radiation, before the cold and the distance and all the walls still waiting further up the climb, there was always this one quiet line, written by a nearly silent man in a small town, that decided the answer before anyone had even begun. And once you understand that the ordinary rocket can never carry us there, the mind does the only thing it can. It starts to reach for something stranger. It starts to ask whether we might cheat the equation altogether, with fires no chemistry has ever known. Consider, first, what happens if we simply refuse the ceiling and push harder in the same direction? There is an engine humanity has already flown that sips its fuel instead of burning through it. A quiet electric thing that pushes charged particles out the back one thin stream at a time. It flew on a small probe called Deep Space One near the end of the last century, and it cruised at something close to 33,000 miles per hour. That sounds enormous, until you set it beside the gap we are trying to cross. So imagine now that you could make that engine 1,000 times stronger, a 1,000-fold leap, the kind of improvement that almost never arrives in any technology, the kind you would build an entire life's work around. Do even that, and the journey to Alpha Centauri would still take you somewhere near 30 years. Not 30 years of gentle coasting. 30 years if everything held, if nothing tore, if the fuel and the patience and the money all outlasted a human career. And that is the hopeful answer. That is the good news, dressed in its very best clothes. So the mind lets go of chemistry and electricity both, and reaches for the only fire large enough to matter. It reaches for the atom. Between the years 1973 and 1978, a group of engineers in Britain, gathered under the name of the British Interplanetary Society, sat down to answer one question with real numbers. Not whether a starship was possible in principle, but what a real one would actually have to be. They gave it a name drawn from old myth. They called it Daedalus, after the craftsman who built wings and then watched them fail in the heat. And what they drew across those 5 patient years is still the most serious starship our species has ever committed to paper. It would not burn its fuel, it would detonate it. Tiny pellets of deuterium and helium-3 dropped into the heart of the engine and struck until each one flared like a miniature star. Not once, not now and then. 250 times every single second, a chain of small suns going off behind the ship, each blast shoving it a little faster into the dark. And with that, on paper, Daedalus could reach 12% of the speed of light. 12%. After every wall we have climbed together tonight, here at last is a design that could cross to a neighbouring star, not in 70,000 years, but in something like 50. The star they aimed it at was Barnard's star, a little farther off than our Alpha Centauri, and it would arrive in roughly one long human lifetime. A child born on the day of launch, growing old as the ship came in. Rest on that for a breath, because it is the closest thing to hope this whole story holds, and it deserves to be cradled gently before we look at what it costs. 50 years. You could almost live it. You could almost picture the crew, or the patient machines standing in for a crew, waking to a sky where the familiar stars have quietly shifted, where our own sun has shrunk to just another point of light behind them, no brighter than all the rest. And then the numbers arrive, the way they always do. Daedalus, fully loaded, would have weighed around 54,000 tons. Hold that mass in your mind for a moment. Not the ship, the fuel. Of those 54,000 tons, 50,000 tons were propellant alone. The vessel itself, the payload, the instruments, the whole reason for going, was only a thin rind of structure wrapped around a fuel tank the size of a small mountain. This is that same quiet line from before, the rocket equation, simply wearing a heavier coat. To go fast, you must carry fuel. To carry that much fuel, you must build something enormous. Roughly 9 parts fire for every 1 part ship. But the true wall was never the size. The true wall was the fuel itself. Helium-3, the isotope those glowing pellets needed, barely exists here on Earth. There is almost none of it in the ground beneath you, not in any amount that could ever matter. To gather enough of it to fill Daedalus, the engineers concluded, you would have to go to Jupiter. You would have to descend into the atmosphere of the largest planet in the solar system, into that crushing weight of gas and endless storm, and mine it there, and haul it back up out of that terrible gravity, and refine it, using floating factories that do not exist, that no one has ever built, that no one yet knows how to build. In order to reach a single star, you would first have to industrialize another whole world. The journey to Alpha Centauri, it turned out, did not begin at Alpha Centauri. It began with 100 years of impossible labor at home, long before the engine ever lit. And so Daedalus was never built. It was never truly meant to be built. It was an honest accounting. A group of careful people looking the problem full in the face and writing down, without once flinching, exactly what it would take. Their answer was not that it could never be done. Their answer was quieter and harder than that. Their answer was simply this: here is the real price. And no one alive on Earth can pay it yet. Notice what has happened, lying there in the dark. We began this stretch of the climb with ordinary rockets and the single line that undoes them. We rose to electric engines and found 30 years waiting even inside the very best dream. We rose again, all the way to controlled fusion, to small stars going off 250 times a second, and we found a ship that could almost make the crossing in a lifetime, and it turned to us and asked us to strip a gas giant bare to feed it. Each rung we reach, the fire grows larger, and the price grows larger with it, always by more than we gained. That is the true shape of this whole story, though we are only just beginning to feel its tilt. The ladder is real. You can climb it, but it leans further away from you the higher you go, and the top keeps its distance no matter how you strain. You do not need to hold any of these numbers. Let them go now, as easily as they came. Let the mountain of fuel dissolve. Let Jupiter drift quietly back into its orbit. Let the little suns go dark one by one behind the ship. None of it is yours to carry tonight. Your shoulders can soften. Your breathing can slow. The weight of all of it can simply pass through you and out into the room. Because there is still one more fire waiting above the fusion pellets. One more thing the mind reaches for. once the atom itself is not enough. There is a fuel that does not release a mere fraction of its mass as energy, the way fusion does. This one releases all of it, every last part, converted whole, into light and heat and motion. It is the single most concentrated power the universe will permit anything to hold. And it is real. We have made it, in vanishing, ghostly amounts, inside one building in Europe. And the moment you learn what it would truly cost to make enough of it to matter, you begin to understand that the wall we have been climbing all this time was never really about engineering at all. It is called antimatter, and the name makes it sound like something dreamed up for a film, some glowing vial wheeled onto a set under blue light. But it is not a fiction. It is the plainest, deepest consequence of the truest thing we know about mass and about energy. The relationship a young man named Albert Einstein wrote down more than 100 years ago. Every gram of ordinary matter, he showed, is energy in a locked and folded form, waiting. When you burn wood, you unfold the tiniest edge of it. When you split a heavy atom, a little more. When you fuse hydrogen into helium, the way those fusion pellets behind the ship were always meant to, you release something close to 0.7% of what is folded inside the mass. And that fraction, that sliver, is enough to light a star for 10 billion years. Everything else stays sleeping, untouched, held inside the matter itself, never spent. Antimatter is the one key that opens the lock all the way. For every kind of particle that builds the ordinary world, there exists a mirror twin, identical in every way, but reversed in charge. A mirror electron, carrying a positive charge instead of a negative one. A mirror proton, carrying a negative charge instead of a positive one. And when one of these twins meets its ordinary counterpart, they do not collide, they do not shatter, they do not scatter into pieces. They simply cease. Both of them, matter and mirror alike, vanish together, and every last part of their mass unfolds at once into pure energy. Not a fraction, not a percent. The whole of it, converted entire, into light and heat and motion. Gram for gram, it is the most concentrated store of energy the laws of this universe will allow anything at all to hold. Nothing you could ever assemble is denser than this. Nothing is more perfect as a fuel. And that is exactly why the mind, having climbed past chemistry and past fission and past fusion, arrives here at the very top of the ladder and reaches for it. We know how to make it. That is the strange and quietly cruel part. This is not a substance that might exist somewhere in theory. We have held it. In one building, on the border between France and Switzerland, near the city of Geneva, there is a machine built for precisely this purpose, and it has been running since the year 2000. It is called the antiproton decelerator, and it is the most sophisticated antimatter factory the human species has ever constructed. Physicists there make these mirror particles deliberately, catch a handful of them in magnetic traps that never touch the walls, and study them for the fractions of a second before they slip free and annihilate. It is patient, delicate, extraordinary work, and you would think, standing in a place like that the door to the stars had finally been propped open a crack. Let that thought sit with you for a moment, in the dark. The fuel is real. We have made it with our own hands. Now let the numbers come, softly, one after another, the way they always do on this journey. That entire facility, running through the whole of a year, produces somewhere between 1 and 10 nanograms of these antiprotons. A nanogram is a billionth of a gram. Picture a single grain of ordinary salt resting on your fingertip. Now imagine dividing that one grain into tens of thousands of smaller pieces, and taking just one of them. That is roughly a nanogram. It is a quantity so small you could never see it, never weigh it on any scale you own, never feel its presence in the palm of your hand. It is, for all the enormity of the machine that makes it, very nearly nothing. And the making of that very nearly nothing costs, in the running of the facility, on the order of $100 million in a single year. So let the arithmetic unfold slowly, and let it settle before it moves. At that rate of production, The price of antimatter works out to roughly $62.5 trillion for a single gram. 1 gram. The weight of a raisin resting in your hand. To hold 1 gram of this fuel would cost close to 2/3 of everything every human being on this planet produces, together, across an entire year. All the farming and building and trading and inventing of 8 billion people, most of a year of it, poured into a mass you would need a fine scale even to detect. It is the single most expensive substance that has ever existed. Not because anyone decided it should be, because the physics of making it, of coaxing these mirror particles into being one by one against a universe that overwhelmingly prefers ordinary matter, simply costs that much. There is no discount waiting at scale. There is only the number. And there is the other number, the one made of time. At the rate that facility works today, gathering enough antiprotons to add up to 1 single gram would take more than 100 years of continuous, unbroken production. A century of the most advanced machine of its kind, running without pause, without failure, without a single day of rest, to make 1 raisin's worth of fuel. A child born the day such an effort began would live a full life, and grow old and pass on before the gram was finished. And here is where the calm has to hold, because the next step is where the ground drops away entirely. A starship does not run on a gram. Every serious study of an antimatter engine, every honest sketch of a vessel that might carry a payload across 4 light years and slow down at the far end, arrives at the same requirement. Not grams, kilograms. Whole kilograms of the most concentrated fuel in existence. And the distance between what we can make and what such a ship would need is not a matter of trying harder, or building bigger, or waiting a few decades for the technology to mature. A kilogram is 1,000 grams. A gram is 1 billion nanograms. Lay those 2 facts against each other, and the gap opens into something the mind cannot really stand inside. Our present capacity falls short of a single interstellar fuel tank, not by a little, not by 100-fold, not by 1,000-fold, but by a factor of roughly 1 trillion. If the arithmetic frightens you, let it go. You do not have to hold it. Let the number pass through you and out into the quiet of the room, the way the others have. It is not yours to carry tonight, but follow it. Gently, just once, all the way down. Suppose the impossible had already happened. Suppose we built not 1 such factory but 1,000 of them, each the equal of the finest we have, all humming together, all producing at the very edge of what physics permits. Suppose we ran every one of them without stopping, without breaking, for 100 years, and gathered up everything they made. If we did all of that, if the whole species bent itself to this single task for a century, we would still be measuring the result in small numbers of grams. We would still stand a very long way from the first kilogram. The ship would still sit empty on the ground. The counterfactual does not rescue us. It only shows more clearly the true height of the wall. And even that is not the end of it, because there is a second problem hiding behind the first, and it is arguably worse. Say you had it. Say by some miracle of centuries the kilograms were finally made. You would then have to hold them. And antimatter cannot touch anything. It cannot rest against a wall, or sit in a tank, or press upon the floor of a chamber, because the wall and the tank and the floor are made of ordinary matter, and the instant the two meet, they annihilate. Everything we make today is held in traps of shaped magnetic force, suspended in a vacuum, kept from touching the world by fields alone, and only in those vanishing ghostly amounts, for the briefest of moments. To store a kilogram this way, to keep it caged and stable and drawn out slowly and safely to feed an engine across years of flight, is not a harder version of something we know how to do. It is a thing no one has done, at any scale by any means. The containment of antimatter in useful quantities is, as of tonight, entirely unsolved. A single failure of the field, a single flicker, and the fuel would find the walls, and the release would be total. So the antimatter dream ends where the others ended, though it is dressed in brighter clothes. The chemical rocket ran out of fuel it could carry. The nuclear ship ran out of a mine that does not exist. And this one, the most concentrated power the universe will permit, runs out on the cost and the time and the impossibility of holding the fire once it is lit. Rest here for a moment, in the dark, with your breathing slow. Notice that something has quietly changed in the shape of the problem. We are no longer only asking whether an engine could be built. We have watched fuel after fuel, each more powerful than the last, arrive and fail in the same direction, and the pattern underneath them is beginning to show itself. Because the deeper you go, the more you begin to suspect that the barrier was never really a shortage of energy at all. Hold that idea gently, the way you would hold something you are too tired to examine closely. Let it rest at the edge of your attention while we follow one last dream, the brightest of them all. The one that seems to answer every objection we have raised so far, because every ship we have imagined tonight has tried to solve the same problem in the same way. Each one tried to push a body of matter through space, faster and then faster, and every one of them broke against the cost of the pushing. But what if you did not push the ship at all? What if, instead, you moved the space? This is the idea that arrived in 1994 in a single quiet paper written by a Mexican physicist named Miguel Alcubierre. He was young then. He had been thinking, the story goes, about the starships of a television show, and wondering whether the equations of general relativity might secretly allow the thing those ships only pretended to do. And to his own surprise, on paper, they did. The idea is this: you do not accelerate through space. You leave the ship sitting still, at rest, inside a small bubble of ordinary space-time, and then you contract the space in front of the bubble, and you expand the space behind it. The ship never moves within its own little pocket. It feels no acceleration, no crushing weight, no 10,000 gravities pressing it flat against the wall. It simply floats, still and calm, while the river of space itself carries the whole bubble forward. And because it is space that moves, and not the ship, there is no cosmic speed limit to break. The bubble can carry you faster than light, without anything inside it ever traveling faster than light. On paper, the 4-year gulf to Alpha Centauri could be crossed in a few weeks. On paper, the entire argument of tonight simply dissolves. You can feel, I think, why this idea has lived for 30 years in the imagination. It does not run out of fuel, because it does not burn fuel to push. It does not tear itself apart on a grain of interstellar dust, because it is wrapped in still and quiet space. It answers, in one elegant motion, nearly every wall we have watched the other ships strike. And that is exactly why it deserves the most careful, most unhurried look of all. Because when a single idea seems to solve everything, the honest question is not whether it is beautiful. The honest question is what it costs. The first cost was there in Alcubierre's own equations, on the very first day. To bend space in this particular way, you do not need energy in the ordinary sense. You need something stranger. You need what physicists call exotic matter. Matter with negative energy density. A substance that pushes outward where everything we know pulls inward. That weighs, in a sense, less than nothing. We have never held a gram of it. We are not certain it can exist at all in the quantities this would require. And when Alcubierre first ran the numbers, the amount of it he needed was not merely large, it was monstrous. The energy demanded exceeded the mass and energy of the entire observable universe. Every star, every galaxy, every scrap of light in every direction, poured into a single bubble around a single ship. Now, that number has come down. In the years since, physicists have refined the shape of the bubble, thinned its walls, reworked its geometry, and in 2012, a researcher named Harold White suggested that with the right arrangement the requirement might fall dramatically, perhaps to the mass and energy of something no heavier than the Voyager 1 spacecraft, a few hundred kilograms of it. That sounds, at last, like a door opening. But listen closely to the words underneath it. That reduction rests on quantum assumptions that have never been tested, on a form of matter no one has ever isolated, shaped in a way no one has ever built. It is a smaller, impossible thing. It is not yet a possible one. And here is where the dream, so calm on its surface, begins to show its true depth. Because exotic matter is only the first wall. Behind it stand at least 4 more, and each one, on its own, is enough to end the journey. The second wall is stability. The bubble, once formed, appears to be a fragile thing, prone to falling apart under the restless quantum churn of empty space, so that the very act of holding it together may be a battle that never ends. The third wall is stranger, and it is the kind of thing that sounds like a story until you follow it carefully. If you can move faster than light in this way, then in the mathematics, under the right arrangement, you also gain the ability to arrive before you left. The warp bubble does not only threaten to break the speed of light, it threatens to break the order of cause and effect itself. It opens the door, quietly, to time travel, and to all the contradictions that come pouring in behind it. And the universe has shown us, again and again, a deep and stubborn reluctance to let that door swing open. The fourth wall waits inside the bubble itself, and it is perhaps the cruelest of them. At faster than light speeds, the calculations suggest, the ship would be flooded from within by radiation, a searing bath of energy building up against the forward wall of the bubble. The still, safe pocket that was meant to shelter the crew would become an oven. Everything inside it would be destroyed by the very crossing it was built to survive. And the fifth wall is the arrival. Suppose, against everything, that you built the bubble, and you held it, and you rode it across the dark. The crew inside, it turns out, cannot reach the wall of the bubble to steer it. They are causally cut off from its outer edge, sealed within their pocket, unable to send a single signal to the front of their own ship. They cannot slow it. They cannot turn it. And when the bubble finally collapses at the destination, the energy it has gathered does not gently disperse. It releases in one burst, a wave of lethal radiation flung forward, ahead of the ship, toward the very world you crossed the stars to reach. You would not arrive at Alpha Centauri. You would arrive as a weapon, announcing yourself by scorching the very thing you came so far to find. So this is the shape of the brightest dream. Not 1 wall, but 5, standing behind a 6th that may not exist at all. And the man who first imagined it has been asked, many times, what he makes of everything his one paper set in motion. He has answered plainly and gently and without any drama. It is, he has said, probably not for centuries if at all. The person who opened the door is the one telling you, softly, not to wait beside it. Rest here a moment. Let your shoulders drop. None of this is anything you need to carry with you. Just notice, at the far and softening edge of your thoughts, what has actually happened across this stretch of the night. We began with a rocket that ran out of the fuel it could carry. We climbed to a nuclear ship starved of a mine that does not exist. We reached for antimatter and found a price the whole Earth could not pay. And then, we abandoned fuel altogether, abandoned pushing, abandoned acceleration itself, and tried instead to move the entire universe around a still and sleeping ship. And even there, in the one place that seemed to slip free of every limit, 5 new walls rose up out of the mathematics to stand exactly where the old ones had. That is the pattern, and by now you can feel its weight settling over you. It does not seem to matter which engine we choose. It does not seem to matter how much power we imagine pouring into it. Every road we walk arrives, sooner or later, at a wall we did not put there, a wall that seems to belong to the structure of the thing itself. And that is the quiet suspicion this part of the night has been carrying toward you, growing a little heavier with each dream we have set down and let go. Perhaps the barrier is not in the engine at all. Perhaps it was never, from the very beginning, a question of how hard we could learn to push. It was a question instead of what we would be forced to carry, and of what would be waiting in the dark to meet us. Because underneath every engine we have dreamed of tonight, underneath the chemical fire and the fusion pellets and the antimatter, and even the warped and folded space-time, there sits one small piece of mathematics that no dream has ever managed to climb over. It was written down in 1903 in Russia by a nearly deaf schoolteacher named Konstantin Tsiolkovsky, working mostly alone, decades before anyone had flown anything into space at all. He was not trying to stop us. He was only describing, honestly, how a rocket must move. And what he found is the wall that every road tonight has quietly run into, wearing a different mask each time. The idea is simple enough to hold as you lie there, even now, even with your eyes closed. A rocket moves by throwing something backward. Fuel goes out the back, and the ship drifts forward. To go a little faster, you throw a little more. But here is the trap, the soft closing jaw of it. The fuel you have not yet burned is weight the ship must carry. And to carry that weight, you need more fuel. And that extra fuel is more weight, which needs more fuel still. It does not add up gently, one step after another. It multiplies. It folds back on itself. To double the speed you finish with, you do not double the fuel. You raise it by a power, until the numbers stop being numbers and start being a kind of refusal. So the problem was never really the engine, not the engine, but the arithmetic underneath it. You want to reach even a fraction of the speed of light, and the equation answers by asking you to build a ship that is almost entirely propellant, a vast trembling tank with a thimble of payload buried somewhere inside it, and then it reminds you softly that you have forgotten something. You have forgotten the second half. Every headline number you have ever heard about reaching another star measures only the going. It measures the ship falling outward, faster and faster, toward the light. It says nothing about stopping. And to stop, to actually arrive rather than tear past your destination in an afternoon and vanish forever into the dark on the far side, you must carry a whole second supply of fuel just to slow down. Fuel to brake. Fuel to carry the fuel to brake. The jaw closes again. The equation does not care which engine you have bolted to the front. It taxes them all exactly the same, and it has never once been paid. But let me set even that aside for a moment. Let me be generous, the way the night lets you be generous with impossible things. Suppose the equation broke. Suppose some future hand reached in and lifted the fuel wall away entirely, and gave you a ship that could reach 1/5 of the speed of light and stop again at the other end, clean and whole. You would still not be safe. Because there is a second truth waiting behind the first, quieter and, in its way, worse. And it is the one almost no one thinks of, because it hides inside a word we all believe we understand. You have been told, all your life, that space is empty. It is the first thing anyone says about it. Empty space, the empty void, the vacuum. And it is one of those things that is true enough to repeat and wrong enough to kill you. So let me take the word apart, slowly, here in the dark, because taking it apart is the turn this whole night has been walking toward. Space is not empty, it is thin. There is a difference, and the difference is everything. Between the stars, in the great dark corridor between here and Alpha Centauri, there is matter. Not much, a scattering of lone hydrogen atoms, drifting, one here, one there, so sparse that you could sweep an enormous volume and gather almost nothing at all. And a fine haze of dust, grains smaller than anything your eye could ever find, floating in the black. At rest, this is nothing. You could stand in it forever and never feel it. It is the most harmless substance imaginable. A single hydrogen atom is the lightest, simplest, gentlest thing that exists. One proton, one whisper of a particle. You breathe past uncounted trillions of them every moment of your life, and they never touch you at all. But now put yourself inside the ship. Put yourself moving at 1/5 of the speed of light. That beautiful, blistering speed we spent so long dreaming of. The speed that was supposed to save us. And understand what that speed does to the word harmless. it turns it inside out. Because from inside the ship, it is not you rushing through the dust. It is the dust rushing through you. That single lone hydrogen atom, that gentlest nothing, is no longer drifting. It is coming at your hull at 1/5 the speed of light, and when it strikes with an energy that has no business belonging to a single atom. A physicist would tell you it arrives carrying nearly 19 million electron volts, and you do not need to know what an electron volt is to feel the shape of that sentence. It is the energy that scientists spend billions of dollars and build machines the size of cities to give to a single particle on purpose, deliberately, inside the great accelerators buried under the ground. That is what an atom smasher does. It takes one tiny particle and floods it with violent energy so that physicists can shatter it and see what falls out. And your ship, simply by moving fast enough to matter, would turn the empty road ahead of it into exactly that machine. Every stray atom in the void becomes a bullet from an accelerator, and there are more of them ahead of you than you could ever count. An endless soft rain of them, striking the front of the ship every second of every year of the crossing. That is only the atoms. The dust is worse. A grain of interstellar dust is still almost nothing. A mote, a speck you would never see. But a speck moving at 1/5 the speed of light does not behave like a speck. It behaves like a small bomb. The energy it carries, the moment it meets your hull, is the energy of an explosion, concentrated into a single point smaller than the head of a pin. And out there, along more than 40 trillion kilometers of open dark, your ship cannot dodge, cannot slow, cannot see them coming. It can only hold its face to the storm and be struck. And struck. And struck again. So we come to the turn, the real one, the one this part of the night has been carrying toward you. The barrier was never the engine, and it was never only the fuel. The barrier is the crossing itself. Not the machine that makes the journey, but the journey. The very emptiness we counted on, the clean open road we imagined between the stars, becomes a weapon the instant we move fast enough to arrive within a human life. The faster you go, the faster it kills you. Speed was supposed to be the answer, and speed is the thing that turns the vacuum into a wall of fire. There is a terrible symmetry in it, and you can rest inside that symmetry for a moment, the way you rest inside anything too large to fight. Go slowly, and the distance defeats you. 70,000 years of it, longer than everything our species has ever built or remembered. Go quickly, and the crossing itself tears the ship apart. The road punishes patience with time, and punishes ambition with ruin, and there is no third setting on the dial. And I have not even mentioned yet what all of this does to a body. Not the ship, but the soft living thing you would have to put inside it. Because even the atoms and the dust are only the impacts you can see coming. There is another kind of harm out there that needs no speed at all, that pours through the walls of any ship we could build, that is waiting the moment you leave the small warm bubble of protection our own star wraps around this world. Out there, in the true deep, beyond everything the sun can shield, a traveler would soak in a rain of radiation from the whole turning galaxy, at a rate many times higher than any dose we have ever agreed a human body can survive. 7 times higher, sometimes closer to 14. Year after year, for the length of a crossing measured not in weeks but in decades. And you can try to build a wall against it. Of course you can. But the wall has mass. And mass, you already know, is the very thing the equation punishes. The weight that demands more fuel, that demands more fuel still. Shield the crew, and the ship grows too heavy to move. Lighten the ship, and the crew slowly dissolves in the dark. Every answer feeds the next problem. Every door you open leans against another that will not. You see now why the suspicion has been growing heavier all night. It was never one wall. It was a house of them, each holding up the next, so that pulling any single one away only drops the weight onto the rest. And we have been standing outside that house, you and I, walking its perimeter in the dark, naming the walls one by one, feeling for a gap. There is a deeper thing under all of it though, a reason the walls stand so close together and refuse, no matter how we press, to move. And that is where the night goes next, softly, with no need for you to follow every step. So let us name the deeper thing, quietly, the way you would name a shape in a dark room once your eyes have finally adjusted to it. It is not a wall at all, it is the floor the walls are standing on. And it was written down long before any of us were born, by a man who never once left the ground. His name was Konstantin Tsiolkovsky, a nearly deaf Russian schoolteacher who worked out the mathematics of spaceflight in a small wooden house in the year 1903, decades before a single rocket ever climbed off the Earth. He was not building engines, he was writing one sentence in the language of physics, and that sentence has never once been broken. Every rocket that has ever flown has obeyed it. Every capsule, every probe, every fragile idea sketched on an engineer's napkin, all of it, without a single exception. We call it the rocket equation. And it is the reason the walls stand so close together that you cannot slip between them. Here is what it says, stripped of its symbols, spoken slowly enough to hold. A rocket moves by throwing mass out behind it. To go faster, it must throw more. But the fuel it throws is also mass the rocket has to carry, which means the rocket must carry fuel to accelerate its fuel, and then more fuel to accelerate that fuel, folding back on itself again and again. It is not that a faster journey simply costs more. It is that the cost does not rise in a straight line. It climbs a curve that steepens the harder you push, until, past a certain speed, almost the entire ship is nothing but propellant, and almost nothing is left for the small thing you actually wanted to send. This is the misconception the whole night has been circling. Most people, when they first hear that the nearest star lies out of reach, imagine the answer is simply a better engine, a cleaner fuel, a cleverer design. Some machine we have not invented yet that will one day light up and quietly close the gap. It is a comforting thought, and it is wrong. Not because our engineers lack imagination, but because the thing standing in the way is not an engine at all. It is arithmetic. And arithmetic does not soften when you feel strongly about it. Consider the finest gentle engine we have ever flown. Not the roaring chemical rockets, but the ion drive, that patient blue whisper of thrust that pushed a small NASA probe called Deep Space One to a cruising speed of around 33,000 miles an hour. It sips its fuel. It is far more efficient than anything that burns. Now imagine we improved it. Not a little, but 1,000-fold, 1,000 times more powerful than the best ion engine ever built. Surely that closes the distance. It does not. Even that engine would still take somewhere near 30 years to reach Alpha Centauri, and only if you never once wanted to stop when you arrived. And there is the quiet cruelty folded into that final phrase. Every travel time you have ever heard for this journey, every headline number, quietly assumes you are content to tear straight through the destination at a fifth of the speed of light and simply wave as you pass. To actually stop, to slow the ship enough to circle a star instead of streaking past it forever, you must carry a second engine's worth of effort, a second mountain of fuel, and you must carry all of it out there first, accelerating it the entire way, so that it is waiting for you when the time comes to break. The equation charges you twice. Once to leave. Once to arrive. Almost no one ever mentions the second bill. So the engineers, being honest people, ask the honest question. What if the fuel itself were perfect? What if, instead of throwing cold gas out the back, you could carry the most concentrated energy the universe will permit, and let that push you? And there is such a substance. It is called antimatter, and when it meets ordinary matter, the two annihilate completely, releasing everything, holding nothing back at all. A few kilograms of it could, in principle, drive a ship toward the stars. For one bright moment, standing out here in the dark beside the House of Walls, this looks at last like the open door. Then you learn the price. At the rate we can make antimatter today, A single gram of it would cost around $62.5 trillion. Not a nation's yearly budget, more than the entire economy of the whole Earth. Everything we make and buy and sell in a year, spent on 1 gram. And that is only if you could buy it, which you cannot, because it is not for sale in grams. The most advanced antimatter factory ever built sits underground near Geneva at CERN, and simply running it costs roughly $100 million every year. For all that money, in a whole year, it produces somewhere between 1 and 10 nanograms. A nanogram is a billionth of a gram. At that pace, making a single gram would take more than 100 years of unbroken work, and a starship would need not 1 gram, but kilograms of the stuff. The distance between what we can make and what the journey demands is not a matter of scaling up a good idea. It is a shortfall by a factor of roughly 1 trillion. The door was only ever painted onto the wall. And this at last is the true shape of the deeper thing. The reason every wall you have walked past tonight refuses so patiently to move. They are not separate obstacles that one lucky breakthrough could sweep aside all at once. They are the same law, wearing different clothes each time, the shielding that grows too heavy to carry, the fuel that must forever carry its own fuel, the perfect substance we cannot afford to make. Each one is only the rocket equation again, asking the same unanswerable question in a slightly different voice. You do not need to hold all of this at once. Let the numbers go loose in your hands. There will be no test in the morning, and the stars are in no hurry whatsoever. Let your breathing slow, and let the weight of it rest somewhere outside your body, out there in the dark, where it truly belongs. Because there is something even underneath the equation. The equation, after all, is only a rule about fuel and mass and speed, and rules, at least in the quiet countries we visit as we fall asleep, can sometimes be rewritten. People have tried. Brilliant, serious people have spent whole careers looking for a way to stop pushing against the universe altogether, and instead to fold it, to bend the distance itself, so that 4 light years is no longer a road you must travel, but a single step across a threshold. Not a faster ship, but a shorter journey. Not more speed, but less space. And the night is about to walk beside them into that idea, gently, and show you exactly what they found waiting there. It is not what the headlines promised. It so rarely ever is. The idea has a shape, and at first the shape seems almost gentle. To hold it, you have to set down something you were taught a long time ago. So set it down now, softly, the way you set down the day. You were taught that space is nothing, an emptiness, a blackness through which things travel. But that is not quite true. Space is not nothing. Space is a fabric, a thing with texture, something that can stretch and sag and ripple, and you are lying inside the proof of it at this very moment. The weight that holds you to the bed tonight, the gentle pressure of the mattress along your back, is not a rope tugging you toward the floor. It is the fabric of space itself, bent by the mass of the whole planet beneath you, curved into a shallow valley, and you have simply come to rest at the bottom of it. Nothing pulls you down. The universe is tilted here, and you have rolled quietly to the lowest place in it. That is gravity. That is the fabric, bending, under a world. And in 1994, a physicist named Miguel Alcubierre asked a question so simple it sounds like something a child might ask, half asleep. If space can bend on its own, he thought, if a planet can dimple it, and a star can pull it into a deep well, then why are we working so hard to move through it? Why fight across the 4 light years the slow way, burning fuel we do not have, when perhaps we could move the space instead? His idea was this, and it is worth turning over gently in the mind. Do not move the ship. Leave the ship still. Instead, contract the space in front of it, squeeze it, gather it up like the folds of a blanket pulled toward you, and at the same time, expand the space behind it. Let it unfurl and stretch away into the distance. The ship sits inside a little pocket of ordinary flat space, a calm bubble, and it never moves at all, not really. It goes nowhere. It simply waits, motionless, while the universe rearranges itself around it. The space ahead grows short, the space behind grows long, and the bubble, with the ship sleeping inside it, is carried forward on that wave of folding space like a leaf resting on a river, going nowhere under its own power, and yet arriving. And here is the part that lit up every headline for a generation. There is no speed limit on this, the rule that forbids you from crossing 4 light years quickly, the great cosmic law that nothing may travel through space faster than light. That law only governs things moving through space. It says nothing at all about space itself. Space is allowed to do whatever it likes. In the very first sliver of a second after the universe began, space expanded faster than light, vastly faster, and broke no law in doing it, because the law was never about the stage, only about the actors upon it. So the bubble may carry the ship as fast as you please, 10 times the speed of light. 100. The ship inside never feels a thing, no crushing acceleration, no pressing back into the seat, just stillness and a window and 4 light years shrinking to nothing outside the glass. Not a faster ship, a shorter journey, not more speed, less space. You can see, lying here, why people fell in love with it. It felt as though a door had been found in a wall everyone believed was solid all the way through, and for a little while in the quiet countries where we go looking for such doors, it almost seemed real. But then you read the fine print, and the fine print, as it so often does, quietly undoes everything. To fold space in this particular way, to squeeze it in front and stretch it behind, you cannot use ordinary matter. Ordinary matter, the stuff of you and your bed and the planet and the stars, bends space only one way. It makes wells, it makes valleys, it gathers space inward. To make the other shape, the ridge, the hill, the pushing away that expands the space behind the ship, you need something that bends space in the opposite direction. You need matter with negative energy, matter that weighs, in a sense, less than nothing. And here the trouble begins, because nobody has ever held such a thing. Nobody has ever seen a gram of it, or a speck, or a single particle. It appears in the mathematics. It is permitted, faintly, in certain corners of the quantum world, in effects so small they are measured between 2 polished plates a hair's width apart. But as a substance, as a thing you could gather and pour into the walls of a bubble, it may simply not exist. It may be a shape the equations allow and the universe forbids. And even if it does exist, there was the matter of how much you would need. When Alcubierre first worked the numbers, the answer was not large. The answer was monstrous. To wrap a single ship in a working bubble, his early calculation asked for an amount of this impossible negative matter whose energy was greater than the mass of everything. Not everything on Earth, not everything in the solar system, everything, every star in the galaxy, and every star in every other galaxy, all the hundreds of billions of them, all the light and all the dust and all the dark, the entire observable universe, converted into fuel, and it would still not be quite enough. Rest on that number for a moment, because it is one of the strangest numbers in all of physics. To take one small ship across one small gap, the nearest gap there is, you would need to spend a universe. The whole thing, and you would still come up short. And if that number makes your mind go soft and quiet, let it. You are not meant to hold a universe in your hands as you fall asleep. Let it be enormous, somewhere far away from you, out past the window, out past the roof of the world. Your only task tonight is to breathe, and to grow a little heavier, and to let the impossible stay impossible at a comfortable distance. So the door in the wall turned out to be painted onto the wall. And you might think that would be the end of it, but brilliant people do not give up on a beautiful idea so easily, and they should not. And in the hush of a night like this, it is a good and human thing that they did not. In the years that followed, others took Alcubierre's shape and pressed on it, and reshaped it, and asked whether the bubble truly needed to be so thick, so hungry. And in 2012, a physicist named Harold White announced that by making the walls of the bubble thinner, by tuning its geometry with a certain care, the terrible number might come down. Not to the mass of the universe, not to the mass of a galaxy, but to something almost gentle by comparison. Roughly the mass of a small spacecraft, around 700 kilograms, about the weight of the Voyager probe that is out there right now, drifting through the dark at the far edge of everything we have ever sent. And for a breath, the door looked real again. From the whole universe, down to something you could lift onto a workbench. That is the kind of leap that puts a warp drive back into the newspapers. And it did. But you have learned, over these last hours, to read the second sentence as carefully as the first. Because White's smaller number does not come for free. It rests on assumptions about the quantum world that have never been tested, never been confirmed, never been held up to the light and shown to be true. It is a promise built on a hope, built on a maybe. The universe-sized answer was real mathematics with a terrifying result. The forklift-sized answer is hopeful mathematics, whose foundations no one has proven will hold. And there is a difference between those two things, a quiet difference. The difference between a bridge that has been measured and a bridge that has only been wished for. And Alcubierre himself, the man who first drew the shape, has never spoken of it the way the headlines do. He has called it, in his own careful words, something that is probably not for centuries. If at all. If at all. Listen to how gently the person who dreamed the dream sets the dream back down. Not never, exactly. He is too honest a scientist to say never, but not soon, and perhaps not ever, and certainly not for anyone lying awake tonight, and certainly not for any child they will ever hold. You do not need to remember any of this. Let the number the size of a universe drift away, and let the smaller number drift off after it. They are not yours to carry. But before you release them entirely, understand that the fuel was never even the worst of it. The impossible matter, the universe you would have to burn, all of that was only the beginning of the objections. Because suppose tonight, in the generous dark, that someone handed you the exotic matter in a jar. Suppose the negative energy simply appeared, gift-wrapped, on the workshop bench. All the trouble of making it already solved. The warp bubble would still not carry you to Alpha Centauri. It would kill you, in more ways than one, and each of those ways is stranger and quieter and more troubling than the last. There are walls behind the wall of fuel. There are at least 5 of them, and the night is going to walk you slowly along each one. Consider the first wall. The bubble that would carry you is not a solid thing, not a hull you could touch or patch or repair. It is a fold in space-time itself, a place where the geometry ahead of you draws inward and the geometry behind you swells outward, and you ride the seam between the two like someone standing on a wave that never quite moves through the water beneath it. A fold held open at the very edge of the possible does not want to stay still. The mathematics say it would tremble. The strange matter that props it open flickers at the smallest scale there is, the quantum scale, where nothing keeps its shape for long, and those flickers would feed on themselves, and grow, and pull the whole delicate structure apart faster than any hand could ever steady it. That is the first quiet objection. The vessel meant to save you is unstable at the level of its own foundations. A cathedral built on moving water that will not hold its surface long enough to lay the first stone. Let that settle. You do not need to follow the equations tonight, only the shape of the trouble underneath them. Now the second wall, and this one is stranger than the first. If you could somehow move faster than light, even inside a bubble that keeps the ordinary rules intact around you, you would not only be crossing distance, you would be loosening the knot that ties cause to effect. The physicists have understood, from the very beginning, that faster than light travel and travel backward through time are the same door seen from 2 different sides. Arrange 2 such journeys, aim them carefully, and a message could return to the one who sent it before it was ever sent at all. An answer arriving ahead of its question. A decision undone by its own outcome. The universe appears to forbid this, gently, the way it forbids so much else. And a drive that props that door open does not merely carry you across the dark. It threatens the one rule that lets any story have a beginning, a middle, and an end. Let your shoulders soften. None of this is yours to solve. Then comes the third wall, and here the danger turns inward, toward the very room where you are lying. When a bubble like this is driven past the speed of light, its leading edge begins to behave like the edge of a black hole, and edges of that kind are never truly empty. They glow. They pour out a searing tide of radiation, particles born from the warp itself, and that radiation has nowhere to travel but into the small pocket of space the ship occupies. The faster you go, the fiercer it burns. You would be riding inside a furnace of your own making, a light with no switch, a heat with no shade, cooking everything it holds long before any destination came into view. The bubble does not simply fail to shelter you, it becomes the thing that ends you, quietly, from the inside. The fourth wall is the softest of them, and in some ways the most sorrowful. Suppose the first three could somehow be answered. Suppose the bubble held its shape, and the causes stayed tied to their effects, and the furnace never lit. You would still be a passenger who can never touch the wheel. Because the walls of the bubble move faster than light, no signal from inside can ever catch up to them. You cannot push against them. You cannot ask them to turn, or to ease off, or to stop. You would be sealed inside a room, carried at an impossible speed toward a point you chose before you ever departed, with no way to change your mind once the crossing began. Everything decided at the start, perfectly, and then handed over to a physics that will not answer when you call to it. You are not the pilot of that journey. You are the letter, already written, already folded, already sealed and sent. And the fifth wall waits at the far end of the road, at the exact place you believed the danger was finally behind you. To stop the bubble, you must let it collapse, and everything it gathered along the way, all that trapped and straining energy, all the particles it swept up along its leading edge across 4 light years of open night, would be released in a single instant. A burst, a flash aimed forward, in the very direction you had been traveling, straight into the place you crossed the whole ocean of dark to reach. You would arrive at Alpha Centauri only to scour it clean. The traveler becomes the weapon. The harbour is destroyed by the simple act of arriving in it. There is no soft landing written anywhere into the mathematics, only an arrival that unmakes the thing it came so far to see. Count them with me now, slowly, one last time, and then let every one of them drift away. A bubble that shakes itself to pieces, a door thrown open onto paradox, a furnace lit inside the cabin, a ship that no living hand can steer, and a landing that burns the harbour down to the waterline. 5 walls, and standing behind all 5, the wall of fuel we already met tonight, the exotic matter, the negative energy, the whole universe you would have to spend just to make the smallest of them. 6 impossibilities, stacked one against the next, and each single one of them is enough on its own to end the whole enterprise. This is the shape the dread takes at its full height, not one obstacle, which a clever mind might yet outwit. A wall, and behind it another wall, and behind that another, each one raised on physics we do not know how to break, and no path between them that anyone has ever found. The man who first wrote the equation understood this more clearly than any of the dreamers who came after him. Miguel Alcubierre set his idea down on paper in 1994, a young physicist working in Wales, and for a little while the world allowed itself to dream on his behalf. Later work, around 2012, tried to shrink that monstrous fuel bill, to bring it down from something larger than an entire universe of energy towards something closer to the mass of a single small spacecraft, perhaps 700 kilograms of it. But those hopeful figures lean on assumptions no experiment has ever confirmed. Quantum slates of hand that may turn out to be nothing at all. And Alcubierre himself, asked plainly whether his drive would ever carry anyone anywhere, did not reach for the easy comfort of soon, or someday, or in our children's time. He said, in his own quiet and unhurried way, that it was probably not for centuries, and then, Softer still, he added the smaller phrase that carries all the weight. If at all. So the warp drive closes like a door in the dark, the same way the nuclear ship closed, and the antimatter engine, and the laser sail, and the patient chemical rocket before any of them. One by one, the vessels we imagined have each been handed back to us empty. And you might think, lying here, that we have finally run out of walls to name, that the fuel and the 5 barriers behind it must surely be the end of the reckoning. Let the thought pass through you gently, and let it go, because it is not quite true. There is one more layer beneath all of these, quieter than the physics of any engine, and it does not ask how we would ever get there. It asks something harder. It asks what, after all of it, would actually be waiting on the other side. And so we come, at last, to the place itself. For nearly all of human history, the honest answer to what waits there was silence. You could stand in a dark field, tip your head back, and find that low bright point in the southern sky, and you would know only that it was a star, or rather 3 stars braided together across a distance too wide to hold in the mind. Beyond that, nothing. No world, no ground, no shore to picture landing on. The nearest sun to our own was a spark and a gulf, and behind it, as far as anyone could prove, there might have been no place at all. Only more emptiness, dressed up as a destination. Then, in the late summer of the year 2016, that changed. A team of astronomers had been watching the smallest and faintest of those 3 stars for years, watching the way it wobbled ever so slightly, trembling back and forth as though something unseen were tugging at it from the dark. And from that tiny, patient tremor they drew a conclusion. There was a planet there. Not a hint of one. Not a maybe, a world, circling Proxima Centauri, the closest star to the sun in all the sky. They named it Proxima Centauri b, and for a few bright days, the whole impossible idea of the journey felt suddenly worth every crushing number we have counted together tonight. Because they said one thing that lit up every headline on Earth. They said it sat inside the habitable zone. Let that phrase settle for a moment, because it is a beautiful one. The habitable zone. That narrow band of warmth around a star where the temperature is neither too fierce nor too bitter. The ring where water, if there is any, could rest on the surface as a liquid, rather than boiling away into vapor or locking solid into ice. The zone where a world could, in principle, hold seas. It is the very thing we have been sweeping the sky for across a whole generation of instruments. And here it was. Not halfway across the galaxy. Not 1,000 light years off in some unreachable direction. Next door. At the very closest address there is. As though the universe, having made the distance so unspeakably cruel, had at least set the prize as near to us as it possibly could, and the planet itself, in those first measurements, was unnervingly familiar. Its mass came in at least 17% greater than the mass of the Earth. Not a swollen gas giant, not a puffed-up ball of hydrogen like Jupiter, all storm and no ground. A small, dense, rocky world, close enough in heft to our own that you could stand upon it and your body would understand roughly what it meant to have weight there. 17% heavier than home. Picture stepping onto a scale on that far surface. The number would climb a little, but not into some other order of being. It would simply be the reading of a slightly larger world, and nothing stranger than that. For one soft moment in the mind, it is almost possible to walk there, to stand on the nearest new ground in the universe and feel it hold you up. But now the very 2 numbers that seem to promise so much begin, very quietly, to turn against us. Because a planet in the habitable zone of Proxima Centauri is not the same as a planet in the habitable zone of the Sun. Our Sun is a large, steady, patient yellow star, and the warm ring around it lies far out, where the Earth floats at a comfortable remove and takes a whole slow year to draw one full circle. Proxima Centauri is nothing like that. It is a red dwarf, the smallest, coolest, dimmest kind of star that there is, holding barely 1/10 of the Sun's mass, giving off so little light and so little heat that its warm ring is pulled in tight against it, huddled close to the embers for want of any warmth further out. So Proxima Centauri b does not orbit at a gentle, comfortable distance. It orbits at roughly 1/20th of the span between the Earth and the Sun, far, far closer to its star than Mercury ever comes to ours. A whole world pressed almost against the furnace, because being pressed against the furnace is the only place on that little star where any warmth reaches at all. The prize sits in the fire's mouth. That is the price of a small, cold sun. To be warm at all, you must live dangerously near it. And when a world circles that close, something happens to it over the long ages that changes everything about what it could ever be. It becomes locked. The gravity of the star reaches out and takes hold of the planet, and it slows the planet's turning gradually across billions of years until the spinning stops altogether relative to the star. One face is then held permanently toward the fire, the other is turned forever away into the dark. Astronomers call this being tidally locked. Our own moon is locked to the Earth in exactly this way. It is the reason you have only ever seen one side of it in your entire life, the same grey face every night since you were a child, and the reason no human eye ever glimpsed its far side until we sent a machine around the back of it to look. Proxima Centauri b is almost certainly locked like that, which means it is not a world of days and nights at all. It is a world with a day side and a night side that never trade places. On one hemisphere, that little red sun hangs fixed in the sky forever. It never rises, because it never set. It is simply pinned to the same spot above the same ground for the whole life of the planet, pouring its heat down without pause, without dawn, without evening. And on the other hemisphere there is no sun at all. There never has been. There never will be. Only a cold that has been deepening quietly for billions of years, a darkness with nothing to break it, a night that has no other side to wake to. You do not need to hold all of this. Let the picture form, and then let it loosen and go. A single world with a burning face and a frozen back, turned always the same way, hanging out there in the dark past everything we could ever reach. None of it is anything you have to carry with you into sleep. Let your shoulders ease down into the bed. Let the strange shape of it drift on past you, the way light drifts through a window and asks nothing of the room it crosses. It is only a fact about a faraway place. It can keep. It has kept for 4 billion years already. And yet, even the burning side, the lit hemisphere, the half that at first sounds as though it might at least be warm enough for something to take hold and live, is not the gentle thing that the words habitable zone would have you imagine. Because Proxima Centauri, small and faint and dim as it is not a quiet star. Red dwarfs are restless in a way our own steady sun is not. They seethe, they convulse, they flare, and Proxima, for all its smallness, flares with a violence entirely out of proportion to its size, throwing off sudden storms of radiation that make our sun's worst tantrums look almost tame. These are not the mild flickers we sometimes see brushing our own sky as gentle curtains of light near the poles. When one of Proxima's great flares erupts, when the star gathers itself and lashes out, the flood of radiation that washes across the day side of that little world can rise, in the fiercest of them, to something on the order of 4,000 times the dose the Earth receives when our own sun throws its very largest storms our way. 4,000 times. Sit with that figure for a breath. Gently, the same way we have sat with every other impossible number this evening. Not 4 times. Not 40. 4,000 times the worst our sky has ever known, falling on a surface that cannot turn away, that cannot rotate into the shelter of its own night, because it has no night to turn into. And then let the mind begin, slowly, to ask what a dose like that, arriving again and again across the ages, would do to anything soft enough to be called alive, on a world held so close to a star that simply cannot hold itself still. And it cannot turn. That is the quiet cruelty folded inside the discovery, and it is worth resting on for a moment, softly, before we go any further. This little world, this Proxima Centauri b, holds one face toward its star forever, the way our own moon holds one pale face toward us, locked in place by the same slow pull of gravity, working across ages beyond counting, until its day and its night stopped moving. One hemisphere stares into the furnace and never looks away. The other is turned into a darkness that has no dawn waiting at the far edge of it, no morning gathering, no promise that the light will ever come around. On the day side, a heat that does not relent. On the night side, a cold that has never once been broken by sunrise. And somewhere between the two, perhaps, a thin ring of permanent twilight, a narrow band that is neither scorched nor frozen, where the story of a kinder world might just barely be whispered. That thin ring is the sliver the headlines seized upon, that late August of 2016, when the measurement was finally published and the newspapers reached for the oldest phrase they had, Earth's twin. A second Earth, only a little more than 4 light years away, sitting in the warm band around its star where water might stay liquid and where life, given time, might find a way to hold. And you can feel why the world wanted it to be true. Here, at last, after all the emptiness, a destination worth the crossing, a shore at the end of the ocean. The measurements themselves are real and gentle in their modesty. A minimum mass of roughly 1 1/5 times the mass of the Earth. An orbit tucked in close, only about 5/100ths of the distance that separates us from our own sun. Close enough that a year there passes in a mere 11 of our days. Close enough to sit inside the habitable zone of a star so dim you could almost look straight at it. But close to a red dwarf is not the same as close to a sun like ours. That is the reversal waiting under the good news. To sit in the warm band of a star that faint, you must huddle in tight against it. And huddling in tight is exactly what leaves you exposed when the star turns violent. And this star turns violent often. We have already sat with the number, 4,000 times the worst our own sky has ever thrown at us, arriving not once but again and again down the long corridors of time. A world that cannot rotate away from that. A world that cannot hide its face. The most careful reading of it, as far as anyone can yet tell, is that whatever atmosphere it may once have carried was most likely stripped away long ago, peeled off into space storm by storm, leaving a surface bared to the radiation with nothing soft between. Not a twin, not a shore, a scorched and frozen stone, held too close to a star that cannot keep still, its thin ribbon of twilight most likely swept clean of any air to breathe, and even that is only one member of the family. Remember where Proxima itself sits. It drifts around the bright central pair, Alpha Centauri A and B, at a distance of something like 13,000 times the span between the Earth and the Sun. 13,000. The system we call our nearest neighbour is not a single warm hearth waiting for us. It is 2 stars locked in a slow dance around each other, and a third faint ember wandering so far out that it takes hundreds of thousands of years to complete a single lap. Not a place. A scattering. A handful of very different fires flung across a gulf so wide that even the members of the family are strangers to one another. So let that settle, the way we have let everything settle tonight. Even if you crossed the impossible distance, even if you solved the fuel and survived the crossing, the thing waiting at the end was, most likely, never the world the headlines promised. Now hold all of that in your mind, gently, all at once, and add to it one last barrier, the quietest of them. The one that has nothing to do with engines or fuel or exotic matter. Suppose your machine somehow arrives. Suppose it opens its small eye and sees something. Anything. A colour in the twilight. A glimmer that stops your breath. It would then have to tell you, and the telling itself takes more than 4 years, because even the message it sends home can travel no faster than the light we have been speaking of all evening. A single word from that distant probe, released at the moment of arrival, does not reach you for 4 1/4 years, closer to 4 1/3. And if you wish to answer it, to send a single instruction back, The round trip stretches to something on the order of 8.5 years, closer to 8 3/4, before your reply could arrive. There is no conversation possible across that gap, no steering in real time, no changing your mind. A craft sent at 1/5 of the speed of light would live alone in the dark for decades, deciding everything for itself, its makers reduced to waiting, listening, hoping the silence would one day break. And here, at the very edge of the impossible, is where a small light flickers. Because people have not stopped trying. There is a concept, quietly sketched at a scientific meeting in December of 2017, with no official name and, as of this moment, no money set aside for it at all. The idea is to launch a laser-driven sail in the year 2069, on the 100th anniversary of the first footsteps on the moon, and to send it out at 1/10 of the speed of light, so that it might arrive around the year 2113, after a crossing of 44 years. A century of patience, opened by a launch none of us in this room will live to see, closed by an arrival our grandchildren's grandchildren might. And it is not the only ember. In 2022, a team in Australia proposed a clever trick, a laser mounted above the atmosphere to correct the shimmer that our own air throws into any beam. In 2025, another group found a way to make the Great Mirror sails far cheaper to build, a design of tiny pentagonal facets that cut the cost of the sail material by something like 9,000 times over, from a figure near $200 billion down toward 25 million. Let yourself feel, for just a breath, the smallness and the stubbornness of that. People still bent over the problem, still shaving impossible numbers down toward the merely enormous. It is a real thing, that progress. It is honest. And this is where the dread folds quietly back in, softer than before, because each of those triumphs solves only a single wall out of the dozen we have walked past tonight. The cheaper sail does nothing about the 100 billion watts of power the launch would still demand. The laser above the air does nothing about the flood of radiation waiting in the deep. Nothing about the dust grains striking the hull like small explosions. Nothing about how a fragile craft is meant to slow down and stop once it arrives, rather than tearing straight through its destination in a single blazing instant. Even a mightier engine, an ion drive 1,000 times stronger than the little one that once cruised at 33,000 miles an hour, would still need something near 30 years for the crossing, because the old tyranny of the fuel never truly lets go. Every solved problem uncovers the ones still standing behind it, patient, unmoved. So the light flickers, and it does not go out, and it does not, tonight, become a fire. And with all of that resting in the quiet of your dark room, we come to the last and gentlest question of all, the one that is not really about rockets at all. The question is this: when you say a thing will never happen, you are making two claims at once, and only one of them is true tonight. You are saying it cannot be done, and you are saying it will not be done. And those are not the same sentence. They only sound the same here in the dark. Everything you have heard tonight lives in the second sentence, not the first. The distance is real. 4.344 light years, a number that has not moved and will not move. Some 41 trillion kilometers of nearly perfect emptiness. But the distance does not forbid the crossing. It only makes it long. The rocket equation is real, that old exponential tax on every gram of fuel, but it is arithmetic, not prohibition. It does not say no. It says expensive, the radiation waiting in the deep, the dust arriving like gunfire, the antimatter that would cost, for a single gram, more than the entire economy of the Earth, the warp bubble that leans on matter no one has ever held, the little sail that must survive being flung to 1/5 of light speed without tearing. Every one of these is a wall. Not one of them is a law that says the thing can never be. Physics, it turns out, is the gentle one here. Physics does not close the door. It leaves the door open and simply tells you how far away the door is, and how much it would cost to walk there, and how long the walk would take. All the walls we have climbed tonight are walls of engineering, of money, of patience, of scale we have not yet reached. They are walls we built, or walls we have not yet learnt to unbuild. They are not written into the structure of the universe. The universe, on this one question, is quiet. It does not say no. It only says, not like this, and not yet, and not with what you have. Consider what would actually have to change. Not the laws. The lasers. 100 billion watts of power. A little over a fifth of all the electricity the United States burns through in a year. Gathered and aimed and held perfectly steady across a single square kilometre of ground. That is not impossible in the way that moving faster than light is impossible. It is impossible in the way a great cathedral was impossible to the person who cut the first stone, knowing they would be gone for lifetimes before the last stone was ever set. The helium that Daedalus needed, waiting in the clouds of Jupiter for a mining fleet that does not exist. The antimatter that trickles out of Geneva a few billionths of a gram a year, when a ship would want it by the kilogram. These are quantities, and quantities are the kind of problem that time and patience sometimes solve, and sometimes do not, but they are never the kind of problem the universe forbids outright. So perhaps the word never is honest. Perhaps no one who will ever share your name, no one who carries your blood forward through all the centuries still to come, will stand beneath two suns and look back at a pale and distant dot and know it as home. Perhaps the crossing stays exactly where it is tonight, a thing designed on paper and never launched, a light that flickers and does not become a fire, or perhaps never is only the name we give to a thing that has not happened during the small window in which we happen to be watching. Perhaps the real barrier is not the distance but the shortness of a human life, the shortness of a human age, the way we measure everything against the span of a single breathing body lying in a single dark room. And here is the part meant only for you, tonight, before you drift the rest of the way down. You do not have to solve this. You are never going to be the one to build the array of 100 million lasers, or mine the helium from the clouds of Jupiter, or hold a kilogram of antimatter still inside a bottle made of magnetism. None of that was ever asked of you. You are allowed to let it be enormous and unfinished and none of your concern. Let the number be large. Let the distance stay uncrossed. You do not need to carry it. You do not need to close the gap tonight, or ever. It is not a debt. It is only a fact, resting out there in the cold, asking nothing of you at all. There is no failure in any of this. It is easy to hear a night like this one as a story of defeat, a long list of the things we cannot do, the ships we drew and never flew, the money promised and then quietly withdrawn, the projects placed on hold and never taken off it. But that is not the true shape of it. To know precisely why a thing is hard, to measure the wall to the centimetre, to name every barrier by its real name and its real cost, is not defeat. It is the opposite. It is the map, and a map of a country you cannot yet reach is still a kind of knowing, still a small lamp held up in a very large dark, and there is a quiet dignity in it, even a peace, that has nothing to do with whether the journey is ever made. Think, if you have any thought left in you, about what it actually means that the nearest star has a name, not a number in a catalogue, a name. Alpha Centauri. We named it because we could see it, and we could see it because its light, 4.37 years old by the time it slips past your window, still crosses all that emptiness and finds us. There is something in that worth holding as you fall. We cannot reach the star, but the star reaches us. Every clear night, a little of it arrives, having left its home before you woke this morning, before this season turned, 4 years and change ago, and it lands on the earth and on the backs of your closed eyes, without any ship at all, without any fuel, without a single one of the walls we spent tonight climbing. That is the strange gift of the speed of light. It is the reason the crossing is so cruel, the fixed and final speed limit that turns 41 trillion kilometers into thousands of years for anything we could ever build. And it is also the reason the sky is not empty to you. The very rule that keeps us here is the rule that lets the light come home. You cannot have the one without the other. The universe that will not let you visit its nearest neighbor is the same universe that sends that neighbor's light to your window faithfully on time, at the only speed it is ever allowed to travel. And that light is old. Every star you have ever wished upon, you are wishing on the past. The Alpha Centauri hanging low in the southern sky tonight is the Alpha Centauri of 4 years ago. 3 suns burning slowly through their long lives. One of them circled by a scorched and battered world we once mistook for a second Earth. A place we may never learn the truth of, because the instruments that could settle it have not yet been built, and may not be built within your lifetime, or your grandchildren's. You are looking at a memory of a place. And the place is still there, still burning, still turning, indifferent and beautiful and utterly out of reach, and it does not need you to arrive in order to go on being real. Rest on that for a moment, the way we have rested on every large thing tonight. The light in your window left its star before certain quiet things in your own recent life had even happened. It has been traveling the whole while, silently, at the fastest speed anything is permitted to move, and even so it took more than 4 years to arrive. That is how far away the nearest thing is. And the nearest thing is the easy one. Beyond it the distances only grow, star after star, each one further than the last, until the numbers stop meaning anything a body can feel. You do not have to feel them. You are allowed to let them stay as words, soft and unweighted, passing through you and out into the dark where they belong. So let the reach go. Let the wanting to arrive there soften, the way your hands have already softened, the way your breathing has already slowed without your ever asking it to. There is a kind of ease that only comes from a thing that is genuinely beyond you, a thing you are not responsible for and could not change even if the whole of your life were bent toward it. The stars are that kind of thing. They ask nothing, they keep nothing waiting. Whether or not a single ship ever leaves this world and crosses that long dark, the light will keep coming, and the distance will keep its shape, and none of it depends on whether you stay awake to think about it. So we come back, one last and softer time, to that single word. Never. It is a heavy word, and people say it as though it were a door slammed shut and bolted, but you have heard tonight what is really standing behind it. Not a locked door, a long hallway. A hallway so long that no one now alive will ever see the far end of it. So long that the walking of it might be handed down through more generations than there are names in your own family that you could name from memory. Never on the scale of a single human life, and never on the scale of the turning universe, are 2 entirely different words that only happen to be spelled the same. So perhaps the ships are coming, slowly, in some century that none of us will live to read about. Perhaps the long hallway is walked by hands that have not yet been born, the work carried along it the way a lantern is passed from one dark room into the next. Or perhaps no one ever goes at all, and the light simply keeps arriving, unanswered and patient, for as long as there is anyone left to stand at a window and receive it. You do not have to choose between those tonight. You are allowed to hold all 3 of them at once, softly, the way you are holding this quiet right now. Because here is the one thing that is yours, and no equation can ever take it back from you. The knowing. You will not build the sail. You will not mine the strange fuel from beneath the clouds of another world. You will never stand on a scorched and frozen shore beneath 2 suns that are not your own. But tonight you have looked at the whole true shape of that distance, and you have understood it, and to understand a thing you can never touch is its own quiet kind of arrival. The crossing that matters most was never the one measured out in fuel. It was this one. The one made of attention. No one can unknow what you now know. It will still be there in the morning, resting quietly under everything ordinary you do. And now step back, as far back as you are able to go. Farther than the probe that will not launch. Farther than the star that will not be reached. From far enough away, our whole small struggle to cross those 40 trillion kilometers becomes a single warm light, flickering on one small world, asking a question the dark has never once answered, and never once refused. That is not a tragedy. A creature that lives for a handful of decades on a stone turning around one ordinary star has learnt the exact weight of a gulf it will almost certainly never cross, and has decided, even so, that the gulf is worth the measuring. A small mind, on a small world, has held the whole ungraspable distance inside itself for one evening, and been made larger by it rather than crushed. There is nothing small in that. There is something close to magnificent. So let the word be heavy, let it be true, and let it be somehow a comfort as well. You are not being asked to close the distance. You are only ever asked to wonder at it, and you have, and that is enough, and it is finished now, for tonight. There is nowhere you have to be. There is nothing tonight that needs deciding. Let your shoulders come down from wherever they have been holding themselves. Let the long numbers you have carried this far slip quietly out of your open hands. They will keep. They have kept through 4 years of travelling light, and they will keep a while longer, until another night when gravity of sleep returns with another question, quiet and enormous, waiting for whenever you are ready to meet it. Not now. Now there is nothing at all left to reach for. Now there is only the dark, and your slow breathing, and the far light still coming, and none of it asking a single thing of you. The far light was never coming for us, only coming, and that, in the end, was always enough.